Stoichiometry Part 2. Mole-mole questions are pretty easy to solve by themselves, but they're not very practical. What is useful is having the given information and the unknown expressed in grams, something we can weigh out. In the next slides, I'll show you how to solve gram-gram problems. First question, how many grams of ammonia can be produced by reacting 1.60 grams of hydrogen gas with an excess of nitrogen gas? So I put the given information and the unknown above their formulas from the balanced equation. Now, since we are talking about grams of each here, I'm going to have to get the number of grams of hydrogen that this represents below it, and the same for the number of grams of ammonia. I'm going to calculate that by taking the number of moles and multiplying it by the molar mass. So for hydrogen, it's 2 grams per mole, and for the ammonia, it's 17 grams per mole. That's 14 plus 3 times 1. Now I'm going to set up my solution. So here's my given information. Here's my unknown. Now I need my conversion factor. So I'm going to need grams of hydrogen down here, grams of ammonia up here. I already have the numbers up here. And that's what it would look like. And then you can see I can cancel out grams of hydrogen and solve it mathematically. There's my answer. All right, let's try another one. I'm going to give you the same reaction, and I put the substances above those in the equation. You notice when it says excess of nitrogen, it really means that it's not going to be a problem. There's more nitrogen than you will need. So we're going to forget the nitrogen. And down below, I put down their gram amounts again. I didn't bother multiplying them out since I'm going to be using them up mathematically. So in my solution, I would need my grams of hydrogen in the denominator, and I want grams of ammonia in the numerator, and it's going to look like that. I would cancel out my units and solve it, and I get 215 grams. And that makes sense if you look at it mathematically. This is like 34 over 6. That's almost 6 then times that. That makes sense. You have 2 more problems to check out, and I'm going to let you do the last one. So here's the third problem. Iron 3 oxide reacts with carbon to give carbon and carbon monoxide. How many grams of carbon are required to react with 16.5 of Fe2O3, and that's iron 3 oxide? So here's my balanced equation. This time I'm not going to bother putting the substances above the formulas. I'm just going to write down the question directly. So there's my given information. I'm given this, I'm looking for that. So in my solution, I'm going to have grams of the iron 3 oxide and grams of the carbon. So here's my setup. So for the iron 3 oxide, if I go back, I look in the formula, there's only 1 mole of it. So it's going to be 1 times its molar mass, which is 2 times the iron plus 3 times the atomic mass of oxygen. And for the carbon, it's just going to be 3 times the atomic mass of carbon, and that's going to go up here. Here we go. And you can see that I can cancel out my units again. Get my pen. And there goes my grams of iron 3 oxide. And then I would just do the math, multiply and divide, and I get my answer. Looks pretty straightforward, I think, by now. So why don't you try the last one? How many grams of carbon monoxide are produced when 36.0 grams of carbon reacts? Here's the balanced equation. Okay, you can pause the video at this time and try to solve it. Remember, you're going to need to write the question down as what are you given, what are you looking for, come up with the conversion factor, cancel out the units, get your answer. All right, pause the video now and give it a try. Come on back and start it again. Okay, here is the solution. So I write down my question. I'm given 36 grams of carbon. I'm looking for grams of CO, that's the carbon monoxide. So in my solution, I'm going to need grams of carbon in the denominator. It's going to be 3 times its atomic mass. and an 8 grams of CO in the numerator, 3 times its molar mass. There you go. Now the 28 is the result of adding 12 plus 16 for the carbon monoxide, and this is just the atomic mass of carbon. Now at this point I could even cancel out some units if I want, and also you go the grams of carbon. I could even reduce the 3's if I want. I don't have to, but I could. And now I just solve it mathematically, and there's the answer. So this is Stoichiometry Part 2. If you have any questions, just email me or let me know in class.